guys, here Mr. G with another video. This time we're going to be doing a video as requested of how to understand a graph. We're going to do one video for a position versus time. This one is going to be for position versus time. And this is what the learners are doing in grade 10. So this one is mostly for grade 10, but applicable to all the grades because everyone sometimes is going to do graphs. So in this video, we're going to focus in position versus time. But before we are able to do graph, let's recall, in previous video, we spoke about position. So let's recall what is position. So remember that position is a measurement of a location with reference to an origin. It is a vector quantity and is a vector that is pointing from the point of reference to the location of that specific object. So let's understand first that one so we can understand graph. For example, let's say somebody is leaving the house in the morning and start walking in any direction, let's say to the right. Now, we need a point of reference. In this case, we're going to take the house as the point of reference. So this one is the point of reference. That is the point of reference, and the point of reference is going to be the origin. So this one is the origin, 0. All right. In this case, we're going to say that right is positive, so this is positive direction, and this direction is negative. Okay? So now this one, guys, is just, this is not graph. We're going to go to graph now, but we must understand this one. So looking at this one, the initial position of this specific person is going to be 0 because it is at the origin, as you can see there. So let's come here and write initial position is equal to 0. But now that person start moving, and sometime later that person is going to be here. For example, it's going to be there. That person is walking in that direction, moving in that direction. Okay, so that person is going to be there. Then let's say, for instance, is 1 to 3 meters. So the second position, for example, when it is there, it is going to be position 2, for example, and is equal to 1 to 3. Let's say 3 meters. 3 meters. And obviously, we need to know how long it took. Let's, for instance, say that it took, let's say, for instance, it took 3 seconds to walk to that specific distance. But the person keep on walking. And after a while, it's going to be 1, 2, 3, another 3 meters more. So, for example, that person later on will be here. There we go. That person continue moving, and so on. That person is going to be moving further away from his house. Okay? That person continue moving further away from his house. Okay? So now, where is the graph problem here? Let's move this 3 because I want to do the graph on this side. Let's move this 3 here. Okay? That is just the time. That is just the time. Time is important because it's part of the graph. So this one is also 3 seconds, and this is hypothetical, 3 seconds, okay? So the idea is to understand how to draw the graph and how to understand the graph. Now, when you have a graph, you always need the axes. So let's move a little bit there. They are the axes, X and Y. In Y, we are going to have position. We're going to understand the position versus time graph in this video, and then next time velocity. Okay. Now this one is the original. The important thing is the following. The origin is going to be the point of reference. So at the origin, you're going to have the point of reference, which in this case is the house. So the house is here. But now I want you to understand something. The house is there, and this x-axis will define in what direction is the object moving from the house. So all these x-axis represent the house and the direction in which the object moving. So this one is very easy. This is the positive direction, and this a little bit further down, which I didn't make provision, let's do the following, going down here, is the negative direction. And that is everything you need to know to understand graph. In this case, what is happening? The person is moving away from the house. Is moving away from the house as the time passes. So the x-axis represents the house. The one side on top, this quadrant here represent the positive direction, and this quadrant here represent the negative direction, this one here. Okay, so when the object is moving away from the house, as the example we're looking here, then will be a line moving away from the x-axis. That is all it happened. This one is the graph. In this case, it's that person that is moving away from the house, which is the reference point. The reference point is always a different point, so it depends what question are we solving. Now, in this case, the object is having a uniform motion. This one is uniform motion. Now, the only difference is the shape of the graph, but the way of understanding the graph is the same. So in this case, for example, for this specific person, the graph will be this one. Let's, for example, have this set of axes once more and represent this specific motion. Now remember, when I speak positive and negative, is for direction. It's not for mathematics, for direction. We're going to speak about that one just now. So this one is position, meters, this one is time, seconds. Okay, so what has happened? Here is 0. Remember, this x-axis, the whole axis represent the house, and the quadrant on top, the first quadrant, represent the positive direction. This person is at the beginning, when start moving, was at position 0. It takes 3 seconds to go to the second position, which was 3 meters. This one is 3, this one is 6, and then maybe here is a 9 every 3 meters. So this is 3, this is 6, this is 9. So when you combine the points here, then you will get that is a straight line. That one is going to be a straight line graph. This is a uniform motion. Now, what do you see this in this specific graph here? The object, as you can see, the line is a line that is moving away from the origin and is going in the positive direction. So object is moving away from point of reference. All right, so saying that, let's see if you get the idea. Let's say if you get the idea here. Let's go to another set of axes. So let's see if we understand this graph, okay? After we explain what is going on, the main basis. First of all, as you see, this graph is a straight line. This is a position versus times graph. As you can see, there is position versus time. Therefore, the motion is a uniform motion. And that is the first thing we know about the graph. Is a uniform motion. So in other words, velocity is constant. All right, now what is happening here? What is happening in this first part at the bottom, the negative part? For instance, what is happening here? Okay, remember, as the time passes, the object is moving. Now, note the following. This graph is moving, or is going to be in this direction. Let me go I don't want to take off that one. This graph is in that direction, okay? So note the following. So in other words, if this one was the point of reference, as we say, this one is the point of reference, this one is the point of reference, okay? We know that one. We explain here, point of reference, always the x-axis. All that one there is the point of reference. What we see, this person or this object was first of all on the negative side. So that person was on the other side of the point of reference. That person was somewhere there. In what direction is moving? Is moving towards the point of reference. Is moving in that direction, and the vector is going to be pointing there. So it means that that person is going to be approaching the point of reference. That is what is happening here as it goes from, let's say, A to B. From A to B, the object is moving towards the point of reference, which is the x-axis. Guys, that is what you see there. What is happening at this specific point? What happened at B? The person is now right passing the point of reference, crossing the point of reference, but it didn't stop there. It continued moving up until it goes somewhere here. If we go to vectors, guys, remember these are vectors that point in like this. That is why it's negative. This is, let's say, position A. There we go. This one is position B, it's right on the axis, and this one will be position C, for example. So here is, at this point is C. Alright, so what is happening? From A to B, the object is moving, or the person is moving towards the point of reference from the negative side, because it's on the negative side of that specific point of reference. It reaches the point of reference, which is the x-axis, and continue moving in the same direction. It's quite simple. It's quite simple. Let's go to another example. We must make sure you understand this one properly. Let's, for instance, see this graph. What we see here, all the shapes are straight line. If there is a straight line, it means the object is moving at constant velocity, or it is a uniform motion. That is important because it's a straight line. So what else we know? Remember, the zero, the x-axis represent the point of reference. Always. Okay, so what we see here, first part of the graph, this one here, object is moving away from the point of reference. He did not start from zero because that object was already some distance away from the point of reference. For example, in this case, we took a tree on a road and the person was not right where the tree is. The person was a little bit away from the tree, and this is the initial position. So that is where that person is standing right now. So what is happening as from, and then give maybe letters to understand better, from A to B. What is happening from A to B? The person is moving away from that tree, as you can see in the graph. It's moving away from the tree. This one is A, and then when the person is here, that one is that is wrong. Let's fix that one there. There we go. When the person is here, this one is position 2, for example, and that one is B. Now, what does the person do now? Turn around. This person turn around. You can see it's moving now towards the point of reference. So this person right there in the positive side, remember we're still in the positive side, all that side there is positive. This is the positive side of the axis. That person turn around and start moving from B. That person turn around and start moving in the direction of the tree. So this one is at point B. That happened at point B. So the person walk all the way up until it reaches the tree. But the person didn't stop there. That one we're talking now about B, C. So we're talking about this part here. We're going to call that one B, C. That person there from B turn around, and here is C. up until it reaches the tree. But guys, the person did not stop there. The person continues moving away from the tree in the negative direction. So after a while, this person is going to be away from the tree in this specific direction, moving there. It is on the negative side of the tree. And we're talking now about this part of the graph. This one is, for instance, D. The person is there at D. Guys, it's quite simple. It's not a big problem. It's quite simple. I hope you understand. Look at the video, take notes, and it's not that bad. Now, if the graph is not a straight line, it's a curve, nothing changes. The only thing that changes is the shape of the graph. So position versus time. If the shape is like this, then the velocity is increasing. This one, velocity is increasing. Now, what is important is the same thing. In this case, the object is moving away from the point of reference. Nothing changed. The only thing that changes is the shape. Everything else is the same. In this case, the object is moving away from the point of reference, as we have here is, for example, A is moving away, but is moving by increasing the velocity. Start to run, that person start running, okay? And then if the velocity start to decrease, then the shape will look like this. It's a curve as well. It will look like this. This one is velocity decreases. That is all. Everything else still the same. Guys, this one is not that problematic. The most important thing is to understand what is going on here. We later on in another video will speak more about graph. I think it's quite important. It's very important, by the way, and I understand it could be tricky to understand. Guys, I hope the video helped. You can write comments. I'm glad that some people are asking me for some videos. That is what I want to do. I want to do videos that you people need. In actual fact, I'm planning to do an experiment for grade 11 about Boyle's law, because some people are asking me for it. And then this one is graph. Somebody asked me for graph. This is graph. This is graph of position versus time. Next time we're going to speak about graph of velocity versus time. I hope this is clear. You can write a comment and say if it's not clear, what you don't understand, and I'll come back and explain over. Thank you for watching. I hope it helps. Subscribe for the channel. Thumb up. I'll see you next time. Mr. G here.